What are the 5 prompting techniques? I mean, if you look up literature, there will be probably more, probably less, depending on where and when you look. But that's like, I think, the main 5 prompting techniques that you will experience. The first one is zero-shot prompting, and we will take a look at all of them. The second one is few-shot prompting. Then we have chain of thought prompting, meta prompting, and finally trunk chaining. So every one of these techniques is pretty much what you might guess from the name. But let's start with zero-shot prompting. So large language models, like all the models we have seen so far, GPT-4, Claude, Gemini, they are tuned to follow instructions and are trained on large amounts of data. Large-scale training, I think I said this a lot, makes these models capable of performing some tasks in a zero-shot manner. So zero-shot prompting means that the prompt used to interact with the model won't contain examples or demonstrations. The zero-shot prompt directly instructs the model to perform the task without any additional examples to steer it, like in this example here. Okay, so classify the text into neutral, negative, or positive, and then I think the vacation is okay, and it will be able to do that. We saw this, I think, a couple of times. This is no problem for most of these big LLM models because they have been trained to do so. Note that it is prompt. We didn't provide any examples of text alongside their classifications because, again, an LLM understands the word sentiment and its meaning. And that's because of the zero-shot capabilities it already has. And this capability mainly stems from something called instruction tuning. And instruction tuning helps AI models get better at answering questions even when they haven't seen similar ones before. And how it works is it works by training the model on examples that include clear instructions about what to do. To make the model even more helpful and human-like, a method called reinforcement learning from human feedback, short LRLFH, is used. This means people review the model's answers and then give feedback. This feedback helps the model learn to give responses that people prefer. I think you see that, for example, not a lot, but sometimes also on ChatGPT, where you get like 2 versions, and then you have to click on the one you like best. That's reinforcement learning from human feedback, and this is why ChatGPT, for example, really the answer really look human-like. So this combination of techniques is what makes those tools work so good today. But when, and there are a lot of cases, when zero-shot doesn't work, it's recommended to provide demonstrations or examples in the prompt, which leads us now to the second technique. And then the second technique is called few-shot prompting. So the prompt will contain one, two, a few examples or demonstrations. And why is that? While large language models demonstrate remarkable zero-shot capabilities, they still fall short on more complex tasks when using zero-shot settings. Few-shot prompting, on the other hand, can be used as a technique to enable in-context learning, where we provide demonstrations in the prompt to steer the model to better perform. The demonstrations here, they serve as kind of conditioning for subsequent examples where we would like the model to generate a response. Well, let's just demonstrate few-shot prompting via an example. So here, the task is to correctly use a new word in a sentence, okay? So we see it's just a totally random word. Wapu is a small furry animal native to Tanzania. An example of a sentence that uses the word Wapu is, you are traveling in Africa and we saw these very cute Wapus. That's the example. So then we follow up with to do a fardoodle means to jump up and down really fast. An example of a sentence that uses the word fardoodle is, and now we hand this over to the model, right? So these are complete random invented words, both of them, but this will work perfectly fine if we have a more difficult task. We can experiment with increasing the demonstrations like from 1 to 3 shot, 5 shot, 10 shot, all right? So here are some tips when doing few-shot prompting. First, grab both the types of labels you use and the kind of text example to show the model. They matter. They matter both, even if the labels aren't always correct. Really, it's better, but there's no need for the labels to be correct. Just having some kind of label, even random ones, is better than having no labels at all. Second, if those random labels are picked in a way that reflects the real-world frequency of labels, instead of being totally random, for example, then the model even performs better. So that's even better than the first one. Also, if you use consistent formatting, the model's performance will again improve. And just a note, the model will still learn, even with incorrect labels, as long as you keep a basic structure. So let me give you an example. Imagine you're teaching someone to recognize, let's say, different animals using flashcards. So even if you sometimes put the wrong label on the animal, like, I don't know, maybe calling a dog a cat, the student will still learn something from seeing images with labels. So showing some label, right or wrong, is better than showing him just pictures with no names at all. And if the wrong labels you give follow a pattern, like maybe the dogs being mislabeled as cats more often than being mislabeled as, I don't know, horses, the student can still pick up on real-world label patterns. So just like the student, the model learns better with some structured guidance, even if it's imperfect or wrong. All right? So overall, it seems that providing examples is useful for solving some tasks. I mean, zero-shot prompting and few-shot prompting are not sufficient. It might mean that whatever was learned by the model isn't enough to do well at this specific task. From here, it is recommended to start thinking about something like fine-tuning your models or maybe experimenting with more advanced prompting techniques. But most of the time, you have to go to fine-tuning or return to fine-tuning. Up next, we can talk about one of the most popular prompting techniques nowadays. It's called chain of thought prompting, and I think it just gained recently a lot of popularity. It's also short. It's called COT. And COT prompting enables complex reasoning capabilities through intermediate reasoning steps. So that's where these reasoning models come from. You can combine it with future prompting to get better results on more complex tasks that require reasoning before responding. So first, take a look at a standard prompt, with no reasoning steps. The question is, Roger has 5 tennis balls. He buys 2 more Kansas tennis balls. Each has 3 balls in it. How many tennis balls does he have now? Answer, 11. Okay, let's go back. 2 times 3 plus 5. Then comes this is the first example. Then comes the real question. The cafeteria has 23 apples. Each they used 20 to make lunch and bought 6 more. How many apples do they have? Okay. And the answer to our question is unfortunately wrong. Okay. Let's just, you can try it out. But let's say the answer is 27 and it's wrong. And it's because we have no reasoning steps in it. So let's take a look what happens when we provide some reasoning steps. Okay, so instead, this time, we say Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each has 3 balls. How many tennis balls? Then we give reasoning in the answer. We don't say the answer is a level. We say Roger started with 5 balls. 2 cans of 3 tennis balls is 6 tennis balls. That's 5 plus 6 equals 11. So the answer is 11. And then we take the same question again. Cafeteria, 23 apples. We use 20 to make lunch. Bought 6 more. How many apples do we have? And look what we get now. Okay? We get the reasoning. It tries to replicate the reasoning. So we had 23 apples originally. We used 20 to make lunch. So they had 23 minus 20 equals 3. They bought 6 more apples. So now they have 3 plus 6 that equals 9. The answer is 9. So now finally, the model replies in the exact same way with reasoning as we have taught it in the example. All right? So that's a very good technique for something that is more complex. It's just a basic, very, very basic example. So don't get me wrong. Probably if you use the latest models, they would be able to solve something like that without any reasoning. But we're not talking about this. We're talking about very complex tasks. Like, I don't know, most of the time you use this for coding and stuff. So just keep that in mind. Good. So let's take it even one step further. Let's go even more complex. What can we do now? We have a technique that is called meta prompting. Okay? And meta prompting is the act to create prompts that help a model to come up with a better prompt itself. So instead of just asking the model to do a task, like, I don't know, write a poem, you are asking it to think about how to ask for that task in the best possible way. So in other words, you're prompting the model to become a prompt engineer itself. So should we use meta prompts then? Always? Maybe, because it will improve results from complex or unclear tasks and also help the model guide itself for a user more effectively. It forces the model to think step by step, and this makes a good prompt. A very good example to see it in action are, for example, prompts to generate images. I don't know if you use tools to generate images, but if you do, you probably have experienced that before. So for example, when telling a model like DALL-E from OpenAI that I want to generate an image of a futuristic city, so please write a detailed and vivid prompt, I can give to an AI image generator, for example, like DALL-E, to get a high quality imaginative image. Let's see what kind of image a simple prompt like generate an image of futuristic city would look like, and how the prompt generated by the model would look like. So that's a prompt we would get from this meta prompt. A sprawling futuristic city at sunset with flying cars zipping through glass skyscrapers, glowing neon signs in multiple languages and floating pipes in the sky. The scene should be cinematic and colorful with dramatic lightning and cyberpunk aesthetic. So you see, the model knows exactly which adjectives to use, which styles to describe, how to describe the expected output. So let's just see what a simple prompt like generate an image of a futuristic city would look like. Not bad, but nothing special. And let's see in comparison what this prompt would look like. Oh, I mean, there's still ways to improve. You can do this 4, 5, 6 times, but you see there's already a big difference in it. It's much more detailed and it's much more reflect what exactly is written in the prompt, right? So that's, for example, something you could use meta prompting. So let's see where we were. Yeah, meta prompting. So we have one more thing. Train of thought. We've done meta prompting. We finished. And the last technique we want to take a look at is prompt chaining. Prompt chaining means we chain multiple prompts and make multiple API calls to the model. Why do we do that? We want to improve again the reliability and also the performance of LLMs. And one of the important prompt engineering techniques is to break tasks into subtasks, smaller subtasks. And once those subtasks has been identified, the LLM is prompted with a subtask, and then its response is then used to input into another prompt. Exactly what I just mentioned with this example. And this is what's referred to as prompt chaining, where a task is split up into subtasks with the idea to create a chain of prompt engine operations. And prompt chaining is useful to accomplish, I would say, complex tasks, which an LLM might struggle to address if prompted with a very long, a very detailed prompt. In prompt chaining, however, chain prompts perform transformations or additional processes on the generated responses before reaching the final desired state. And besides achieving better performance, prompt chaining also helps to boost the transparency of your LLM applications, because it increases controllability and also reliability. This means that you can debug problems with the model responses much more easily, and then also analyze and improve performances in different stages, and only in those stages maybe that need improvement, while others don't. So prompt changing is particularly useful when building LLM-powered conversational assistants and improving the personalization and also improving user experience with your applications. So let's do a very simplified example again. Let's say you need to write a product ad. Yeah. So your first prompt could be, give me an idea, give me some ideas for new kitchen gadgets. And the answer could be something like let's go for a magnetic spice dispenser. And then you take that and you then feed it into another prompt, like write a product descriptions for this spice dispenser. So the output could be, I don't know, the Spice Snap is a sleek magnetic dispenser that keeps your spices fresh, organized, and within reach, something like that. And then the final prompt could be, now turn this description into a short, catchy ad, for example, for Instagram, which could result in tired of messy spice racks, meet Spice Snap, your magnetic kitchen hero, #kitchen hack. So each of these 5 steps, is it 5 more? 3 steps, is an API call, and one refined task, and this will eventually lead to a stronger final result, right? So that's the last part. That's the last prompting technique of prompt engineering, prompt chain.